Today we're talking about solutions to equations. Go ahead and try these three and I'll be back in just a second to show you the answers. Okay, so let's inspect these further. Take out your red pen and let's check our work. On this one, we would need to add 20 to both sides. When you do that, you get 1/4 x on this side equaling 80. Remember, you can always add in your lines if you'd like. We're going to multiply by 4 on both sides, and when we do that, the 4's cancel out, or the 4 cancel out to the 1/4, so we're left with x, and 80 times 4 is 320. Over here, you distribute a 4 to both sides, and you're left with 32 equaling 4x plus 20. If you take 20 away, you're left with 12x on this side, or excuse me, just 12, and 4x on this side. You divide by 4 so you can get x by itself, and x equals 3. Over here, we get a 8. We're going to add 8 to both sides, so all we're left with is 3x equaling 3x, and when we divide by 3, we get x equaling x. What's going on here? Some of you might have even solved it like this. You took and you got rid of the 3x first, and so now you just have a -8 equaling a -8. Something crazy is going on here. Let's inspect it further. If we look at this one and we take the 8 away and we're left with this x equaling x, well, this means that we can plug any number in for x and it would be a solution. For example, if I plug in 2, 2 equals 2. If I plugged in 5, 5 equals 5. If I plugged in 6, then 6 would equal 6. So it has infinitely many solutions. Please star this problem and write down infinitely many solutions. So, how many solutions does an equation have? That's our goal to find out. We're going to isolate the variable to one side and get all the constants on the other side of the equal sign. Okay, so the goal is to never lose those variables like we might have done over here where we have this -8 equaling a -8. Okay, so make sure that we isolate each side. Let's try this one. First, let's simplify. So we get 6 times x minus 18 plus 10, and then over here, 2 times 3x is 6x. 2 times a -4 is a -8. So we get 6x minus 8 equaling 6x minus 8. That's a true statement, right? These equal one another. But just because they want us to, let's go ahead and isolate the variable. So we're left with 6x equaling 6x. And when we divide by 6, we're left x equaling x. So this means we have infinitely many solutions. Okay, let's look at another one. Go ahead and try this one and I'll be back in just a second to show you what I did. Okay, have your red pen handy. So we're taking 8 times 4 and 8 times 2x to get 32 minus 16x. We're going to take 4 times 3 and it times the -5, and we get 12 minus 20x plus 4x. Combine these and we get 12 minus 16x equaling a -16x with the 32. Okay, so let's isolate the variable. Let's take 12 away from both sides, and we get 0 on this side with our 16x, so it's -16x equaling -16x and 20. Add 16x to this side, and something crazy is going to happen here. We're going to be left with 20 equaling 0. That's not true. So in this case, the answer is no solution. We have no real numbers that can be plugged in for x for this to work. So I want you to take a second and we're going to examine all the possible options. For a number of solutions, you could have no solution, one solution, or infinitely many solutions. Sometimes you'll see the word null set, one solution, or identity. I want you to take a second, pause the video, and copy down this entire slide. It's got examples for you of what no solution looks like, just like the last one we did. one solution looks like, which was all the problems that we've done in the previous videos, and what identity looks like. All right, so make sure you have that copied down. I want you to try these two problems for me, and I'll be back in just a second to show you what I did. Okay, grab your red pen. We're going to look at each one of these. In this one, we're taking 3 times 6, and we get 18. 3 times a negative 4 is a negative 12x. Over here, negative 2 times 6x is negative 12x. Negative 2 times 9 is positive 18. So if we take 18 away from both sides to try to isolate the x, we get negative 12x equaling negative 12x. If we divide by a negative 12, then x equals x. This is our identity, or all numbers. So we can say infinitely many solutions. Okay, in the next one, take 2 times 3x and get 6x, 2 times 5 and get 10. Then over here, take 5 times 2 and get 10x. 5 times a negative 4 and get negative 20. Bring down your negative 4x. So when we simplify, we get 6x minus 20 equaling 6x plus 10. Take the 10 away. We're left with 6x equaling 6x minus 30. Take 6x away from this side to get it isolated. And we're left with 0 equaling a negative 30. Okay, so this is a null set or no solution. These are the two phrases that you're going to see most often and what you need for the test. Okay, go ahead and try these, and I'll be back in just a second to show you what I did. All right, grab your red pen. 6 times x is 6x. 6 times negative 3 is a negative 18. Bring down your 10. 2 times 3x is 6x. 2 times a negative 4 is a negative 8. So when we combine over here, we get 6x minus 8 equaling 6x minus 8. I'm okay if you stop here, because this right here means that if I take 8 away from both sides, I'm left with 6x equaling 6x, and then x has to equal x. So this one is infinitely many solutions. Okay, over here, we're going to add 2x to both sides, and we're going to get rid of the 19 on this side. Okay, so these cancel out, and these cancel out. I'm left with 9x over here, and 63 over here, which means I have to divide 63 by 9 on both sides, and I get 7. So this is one solution. Try these two for me, and I'll be back in just a second to show you what I did. Okay, grab your red pen. You're taking 60 times a fourth. So what you really have here is a multiplication problem that looks like this, which means you can simplify and get 15. You're doing the same thing with the 1/4 with the 16x. You're going to keep the x, but 4 and 16 cancel out, so you're left with 4x. So this is what we're left on each side. Okay, so if we get rid of the 15s, we're just left with 4x equaling 4x. If we divide by 4, we're left with x equaling x. So this is, again, infinitely many. Here, we're going to take 12x minus 6 and 12x minus 4. Can that be possible? The answer is a big fat no, because the negative, if we take away the 12x on both sides, we're going to be left with a negative 4 equaling a negative 6. Or if you moved them and then did it, you would end up with 0 equaling a negative 2. So this is no solution or that null set. All right, I'm going to leave you with 3 more. And so what do we end up with when the answer is identity, all numbers, many solutions, null set or no solution, and one solution? Copy this slide down. So what we are left with for identity is x equaling x. What we're left with null set is a number equaling another number, okay, in which they are not the same, okay? So some number does not equal another number. For example, 5 does not equal a -6. And one solution, you're left with x equaling some number. Any number. Just one of them, though. One solution. Okay? And that's all I've got for you today.